So now we're going to dig into the first application of what we're doing for derivatives, which is really finding that equation of the tangent line. So remember that the whole point of us doing all that derivative was to help us calculate the slope of the tangent line. But now we actually want to find the actual equation of that line. And just to remind you, remember, if we have a function of some curve, what we mean by a tangent line is some line that just touches the curve right at that one point, right? That's the tangent line, and we want this equation. How do we find the equation? Now, what we're going to rely on is some old algebra principle. You might have learned in pre-calculus, might have learned algebra 2, might have learned a while ago, but we're just going to revisit it, is the point-slope form. I know it's very common to use slope-intercept form, but point-slope form is a lot easier because point-slope form is the fundamental thing of what we're going to use to find the equation of the tangent line. Because it's a given a point on a line, and say the point is x0, y0, and a slope, m, then this is the equation of a tangent line. And it's very common to use this. This will be very common to use. This is the standard way. We're not going to use slope-intercept form. I know some people do like their point, and then you plug it into y equals mx plus b and solve for b. I find that very error-prone. This is a much more simple way and more direct way to solve for the equation of the tangent line. Okay, so here's the thing, is our goal is to figure out two pieces of information. We want to find the point on the curve, and then that's usually easy, and then we find the slope of that curve by computing the derivative at that particular point. Okay, so let's go through an example here. So suppose I have the function f of x is equal to x squared plus 3x, say, plus 5. And I want the equation of the tangent line. I want the tangent line at say x equal, say, 1, okay, at when x is equal to 1. So the first thing I want to do is I want to find the y coordinate of the point. I want to know what my point is. Now the point is 1 comma something. How do I find the y value? Well, it would be the value of the function at 1. I would plug 1 into here, and that would be 1 squared plus 3 times 1 plus 5. And that would be 1 plus 3 plus 5, which is 9. So the point is 1, 9. So that's the first piece of thing where I was trying to solve for. The second is the slope. And the slope here, to compute the slope, we would first compute the derivative. The derivative of x squared is just 2x. Derivative of 3x is 3. And derivative of 5, which is constant, is 0. And so our slope is actually the value of the derivative at that point, right? Because the derivative changes for different values of x. So we want this, where do I want the slope at? I want the slope at this point. So I want to plug in 1, and I would get 2 times 1 plus 3, which is 5. So now I know my slope is 5, and using slope point form, then you would say it is y minus 9 is 5 times x minus 1. That's what this form here is telling you. And that would be the equation of the tangent line. Okay. I want to actually show you what this looks like when we grab the graph. So let's do our graph. Oops. Okay, so that is our equation. That is our parabola here. And now let's compute this. Y minus 9 is 5 times x minus 1. So now I've created I've plugged in our tangent line, and you can see there right at 1, 9. The blue line is a straight line, and it just touches that curve there, right? It glances it, just touches it, and then but doesn't pass through the curve. If you zoom in, it doesn't cross it. It just touches the curve right at that point. And that's what we're looking for. That is the equation of the tangent line. Okay, now suppose there's another thing we call a normal line. Normal line is not as common to necessarily talk about. Normal line is the line perpendicular to the tangent line at that point. Okay? So it's the same idea, and I don't know if you remember, but lines that are perpendicular, their slope is equal to -1 over m. Let's go 1 over the like if a line has a slope of 2, the line perpendicular has a slope of -1/2. So if a line has a slope of 2, then the perpendicular line would be negative 1/2. You do a negative reciprocal, that will give you a line that's a 90-degree right angle. And the normal line is just as simple because the point is the same. Like if I wanted the normal line for this point, the point is still 1/9, right? But the slope, instead of being 5, would be negative 1/5. So the normal line would be y minus 9. That's my point on that line. And then the slope is negative 1/5, right? And that's why slope point form is so much more useful, because it's really easy. And let's plug that into Desmos here. Let's take a look at what that looks like then. So we would say y minus 9, equals negative 1/5 times x minus 1. And you can see here, I don't know if you can tell, between that blue and that green line, they both go through the point 1/9, and they are perpendicular to each other. They're right angles. That's what we call a normal line. So if I hide this thing, the normal line goes through that point on the curve, but makes a right angle with the curve right at that point there. Okay, so that's the general process for finding tangent lines and normal lines. And then the next section will kind of go through a bunch of examples of calculating more tangent lines and normal lines. But the basic idea, just to recap, is you want to find the point and you want to find the slope. And the slope is either the derivative, or if it's for tangent line, or it's the negative reciprocal if you're finding a normal line. Thanks for checking out this video. I hope you found it really helpful. If you'd like more support, maybe you need more multiple choice practice, maybe you just need more guidance and things like that, I have plenty of information on my website. If you look in the description below and go to www.bothellstemcoach.com, I will explain all the ways I help students be successful in their AP classes.